Some decades ago, the English Channel 4 TV station broadcast a documentary program entitled "It Runs on Water." The program was not particularly informative and had no information on how to research further into the subject. But through that program I became aware that there was such a thing as free energy. The most interesting section of the documentary was an introduction to the work of Stan Mayer of America. Stan gave a brief demonstration of his water fuel cell, which is a device for converting water into gas, not actually by electrolysis, but instead by a process called water splitting, which uses very little electrical current and does not generate heat in the process. Stan's cell looks like this. It is a transparent plastic container with metal pipes inside it. It has pairs of alloy pipes, with one pipe enclosing the slightly smaller inner tube. The tubes are 15 inches, which is 380 millimeters long, and they are immersed in tap water. However, probably not city tap water in America, as that is laced with chemical additives. The tops of the tubes can be seen clearly here. The tubes are not connected together electrically in any way. The inner tubes don't actually touch the outer tubes. There's a small gap between them. The outer pipes are supported by individual metal brackets, and the brackets are seen here in this photograph. Photographs don't convey nearly as much information as diagrams do, so I have sketched what I believe to be Stan's method of construction. The base of the plastic see-through cylinder is a plastic plug end, if you like, which has got a rubber O-ring as a seal against the pipe itself. Inside the actual device then you have a metal plate, and attached to it a number of vertical inner metal pipes. The metal pipes are made of an alloy, if what Stan says is to be believed. The inner pipes are welded to a common plate. It's bolted to the sealing cap for the acrylic tube, which forms the body of the water fuel cell. Then outer tubes are individually supported on a common 9-arm plate close to but not touching the inner pipes. And generally speaking, this is the way that the system looks. That style of construction allows each outer pipe cell to oscillate at its own exact frequency. Using pipes which are 15 inches long makes a cell which looks like this when valves, a filler cap and a pressure gauge are attached to it. Stan is just finishing filling up the container with water. It's a tall container compared to its width. That's not an essential feature, it just happens to be that way with his design. When power is applied through his circuitry to those pipes, the rate of gas bubble production is so high that the whole cell is filled with bubbles, and that obscures everything else that's inside the cell. The inner tubes are much longer than the outer tubes, and those outer tubes have a tuning slot cut in them so that they can all oscillate at exactly the same frequency. However, the sudden and unexpected death of Stan Mayer prevented the publication of exact details, and so nobody managed to replicate it for a considerable period of time. The first replication came from Dave Lawton of Wales. By using very considerable tenacity, he discovered the practical details of how to replicate one of Stan Mayer's early designs, which is called by the rather confusing name of the water fuel cell. Dave's work was copied and experimented with by Ravi Raju of India, who had considerable success and who posted videos of his results on the web. Video of Dave Lorton's replication of Stan Mayer's demonstration electrolyzer, which can be seen at free-energy-info.com/WFC-rep.WMV, has caused several people to ask for more details. The electrolysis shown in that video was driven by an alternator solely because Dave wanted to try each thing that Stan Mayer had done. Dave's alternator and the motor used to drive it are shown in these two pictures here. The technique of DC pulsing requires the use of electronics, so the following descriptions contain a considerable amount of circuitry. If you're not already familiar with such circuits, then you would be well advised to read through my electronics tutorial at free-info.com/chapter12.pdf, which explains this type of circuitry from scratch. The field coil of David's alternator is switched on and off by a field effect transistor, that's an FET, which is pulsed by a dual 555 timer circuit. This produces a composite waveform which produces an impressive rate of electrolysis. The tubes in this replication are made of 316L grade stainless steel. They're only 5 inches long, although Stan's tubes were 15 or 16 inches long. The outer tubes are 1 inch in diameter, and the inner tubes are 3/4 of an inch in diameter. As the wall thickness is 1/16 of an inch, the gap between the two tubes is between 1 mm and 2 mm. It is the oscillation of the water inside this gap between each pair of tubes which splits the water. The inner pipes are held in place at each end in Dave's method by 4 rubber strips about 1/4 of an inch long. The container is made from 2 standard 4-inch diameter plastic drain downpipe coupler fittings connected to each end of a piece of acrylic tube with PVC solvent cement. The acrylic tube was supplied ready cut to size by Wake Plastics, 59 Twickenham Road, Isleworth, Middlesex, TW7 6AR. The seamless stainless steel tubing was supplied by metalsontheweb.co.uk. It is not necessary to use an alternator. Dave just did that because he was copying each thing that Stan Mayer did. The circuit without the alternator produces gas at about the same rate and obviously draws less current, as there's no drive motor to be powered. A video of the non-alternator operation can be seen at this location, which is free-energy-info.co.uk/WFC-rep2.WMV. Dave's electrolyzer has an acrylic tube section to allow the electrolysis to be watched, as shown in these photographs here. This is Dave's cell, and this is a close-up of the cells just after the power has been switched on. The electrolysis takes place between each of the inner and outer tubes. The picture above shows the bubbles just starting to leave the tubes after the power is switched on. The picture below shows the situation a few seconds later, when the whole of the area above the tubes is so full of bubbles that it becomes completely opaque. The mounting rings for the tubes can be made from any suitable plastic, such as that used for ordinary food chopping boards, and they're shaped like this. Dave only used 6 pairs of pipes, and this dark material is actually plastic, even though you don't expect plastic to look that colour. The 316L grade stainless steel seamless tubes are held like that, with being pushed into this bottom piece, the base made from plastic. Here's the assembly ready to receive the inner tubes. The inner tubes are wedged in place by small pieces of rubber. The electrical connections to the pipes are via stainless steel wire running between stainless steel bolts tapped into the pipe and stainless steel bolts running through the base of the unit. You can see the arrangement here in this diagram. This diagram is simplified in that it shows just one of the pairs of pipes. That's for clarity. The plastic mounting ring is shown there in brown. The transparent acrylic tube is shown pushed into, if you like, and glued to the base part of this diagram. You have a stainless steel bolt and stainless steel wire going to a stainless steel nut and bolt solder tag and connection to the input voltage plus, and the same on this side. The input voltage minus comes through the stainless steel bolt up along the stainless steel wire and connects to a nut, and well, not a nut, a bolt, a very short shaft bolt screwed into the inside of the inner tube. That's the way that Dave has opted to do the build on this particular design. The bolts tapped into the inner tube should be on the inside. The bolts going through the base of the unit should be tapped in to give a tight fit, and they should be sealed with Sikaflex 291 or marine goop bedding agent, which should be allowed to cure completely before the unit is filled for use. An improvement in performance is produced if the non-active surfaces of the pipes are insulated with any suitable material. That is, the outsides of the outer tubes and the insides of the inner tubes, and if possible the cut ends of the pipes. This is the drive circuitry used by Dave for this system of water splitting. He has a bifilar coil wound to drive the row, in his case, of 6 pairs of pipes. Watch how the connections are made though. The outer pipes are connected along the red wire to the finish of the winding shown in red, and the start of the winding shown in red is connected to the positive line of the supply to the cell. Pay attention to the other cells. The inner pipes are connected along the blue wire to the start of the black coil, not the finish but the start. The starts are shown by the black dots at the end of the coil symbols. They're being driven by a very fancy FET transistor, which is a BUZ350. That's a very high performance industrial quality field effect transistor. It's driven fairly sensibly by just a straight voltage connection between the output pin 3 of a 555 timer, which is wired to produce a quite fancy waveform, because 2 555s are being used, one to generate a base frequency with switching the other one on and off. The high frequency one has got the option of you choosing one of 3 different capacitors of fairly small value. The fastest waveform is using a 10 nanofarad capacitor. The second is 100 nanofarad capacitor, and the slowest of these three is the 220 nanofarad capacitor. That gets this oscillator here running fast, but that very fast signal is being switched on and off by the signal coming from this 555, which is much slower in that it has the options of a 1 microfarad capacitor, 1 microfarad capacitor, or a 10 microfarad capacitor, or a 47 microfarad capacitor. The circuits here are using 1N4148 diodes. That's a very fast and very cheap diode. They operate extremely fast in that they switch fully in just 3 nanoseconds, and that's very good for such a cheap and versatile diode. The reason for the diodes is that you have an adjustable frequency, which is what feeds the capacitor and sets the speed, but you also have a variable frequency marked space ratio, where the on time and off time are adjustable. The two 555 chips are each individually fed by a smooth power supply, which is a 100 microfarad capacitor being fed by a 100 ohm resistor. It's not a very serious method of decoupling the 555 chips, but it is quite effective in this circuit. It's certainly sufficient for the needs of this particular operation. The main part of the circuit is made up of these two 555 timer chips. They're wired to give an output waveform which switches very rapidly between high voltage and low voltage. The ideal waveform shape coming from this circuit is described as a square wave output. In this particular version of the circuit, the rate at which the circuit flips backwards and forwards between high and low voltage, called the frequency, can be adjusted by the user turning a knob. Also, the length of the on time to the off time, which is called the marked space ratio, is also adjusted by just turning a knob. The circuit is shown there where you can see it clearly. The output is from pin 3 of the actual chip. The same circuit is used for the slower running version of the square wave output, and they work very well together. The thing is that the slower one is used to switch the faster one on and off, and that gives you a very nice waveform, which is a row of fast pulses, a gap, and another row of fast pulses. And you can adjust the width of the pulses, and you can adjust the gap between the groups of pulses. And that is the waveform that's been used in Stan's system. It's a very effective and very simple method. The field effect transistor boosts the output, and the load, which, as I pointed out before, has the pairs of pipes connected in a slightly unusual way, in that the positive line feeds the start of the coil shown in red, and the other pipes are connected to the start of the coil shown in black. And that is the arrangement that works extremely well in this particular circuit. It's worth mentioning that this has a maximum current output of about 2 amps. It is not a pulse width modulation circuit or DC motor speed controller for high current DC electrolysis. The current draw in this arrangement of Stan Mayer's is particularly interesting. With one tube in place, the current draw is about 1 amp. When a second tube is added, the current increases by less than half an amp. When the third is added, the total current is under 2 amps. The fourth and fifth tubes add about 100 milliamps each, and the sixth tube causes almost no increase in current at all. This suggests that the efficiency could be raised further by adding a large number of additional tubes. But this is not actually the case, as the cell arrangement is important. Stan Mayer ran his Volkswagen car for 4 years on the output from 4 of these cells with 16-inch electrodes, and Stan would have made a single larger cell had that been feasible. Although the current is not particularly high, a 5 or 6 amp circuit breaker or fuse should be placed between the power supply and the circuit to protect against accidental short circuits. If a unit like this is to be mounted in a vehicle, then it is essential that the power supply is arranged so that the electrolyzer is disconnected if the engine is switched off. Passing the electrical power through a relay which is powered via the ignition switch is a good solution for this. It's also vital that at least one bubbler is placed between the electrolyzer and the engine to give some protection if the gas should be ignited by an engine malfunction. The physical connections to 555 chips and the BUZ350 field effect transistor are shown here in this diagram. Although printed circuit boards have now been produced for the circuit and ready-made units are available commercially, you can build your own using stripboard if you want to. A possible one-off prototype style component layout is shown here. The red dots in this indicate where the horizontal horizontal copper strips on the underside of the plastic board are broken. So the red dots show the break in the horizontal copper strips on the underside of the board. That is an arrangement which works perfectly well with the circuit. If you were to turn that board over horizontally, this shows where the actual breaks in the strip are physically made. The unit can then be enclosed in a plastic box, and the various operations of the components that you're going to be using are shown there. You have the incoming direct current from a battery there, and the output of the direct current, or should I say the output of the oscillating direct current, comes from the other pair. But that is purely a matter of your choice. You don't have to do it that way. You can if you want. This is the arrangement if in that box. If you lift the underside of the box, which is meant to be the lid originally, off, and you can see how the wires connect to the various components in your physical construction. Although a ferrite ring is probably the best possible option, the bifilar coil can be wound on any straight ferrite rod of any diameter and length. You just tape the ends of 2 strands of wire to one end of the rod, and then rotate the rod in your hands, guiding the strands into a neat side-by-side cylindrical winding, as shown in this diagram. So the red wire from the plus and the blue wire from the rest of the circuit are wound side by side, touching each other along, in this case it is a 3/8 inch or 8 millimeter ferrite rod, and that's the way that the arrangement works for this particular build of the components. The list of the components used there are shown in the table, and Dave, who built this replication, suggests various improvements. Firstly, Stan Mayer used a larger number of tubes of greater length. Both of those 2 factors should increase the gas production considerably. Secondly, careful examination of video of Stan's demonstrations shows that the outer tubes which he used had a rectangular slot cut in the top of each tube. Some organ pipes are fine-tuned by cutting slots like that in the top of the pipe to raise its pitch, which is its frequency of vibration. As they have smaller diameter, the inner pipes in the Mayer cell will resonate at a higher frequency than the outer pipes. It therefore seems probable that the slots cut by Stan are to raise the resonant frequency of the larger pipes to match the resonant frequency of the inner pipes. If you want to do that, hanging the inner tube up on a piece of thread and tapping it will produce a sound at the resonant pitch of the pipe. Cutting a slot in one outer pipe, suspending it on a piece of thread and tapping it will allow the pitch of the two pipes to be compared. When one outer pipe has been matched to your satisfaction, then a slot of exactly the same dimensions will bring the other pipes to the same resonant pitch. It's not been proved, but it's been suggested that only the part of the outer pipe which is below the slot actually contributes to the resonant frequency of the pipe. That is the part marked H in the diagram above. It's also suggested that the pipes will resonate at the same frequency if the area of the inside face of the outer pipe exactly matches the area of the outer surface of the inner pipe. It should be remembered that as all of the pipe pairs will be resonated with a single signal, that each pipe pair needs to resonate at exactly the same frequency as all the other pairs. It's said that Stan ran his Volkswagen car for 4 years using just the gas from 4 of these units, which had pipe pairs 16 inches long. A very important part of this cell build is the conditioning of the electrode tubes using tap water. Ravi in India suggests that this is done as follows. 1. Do not use any resistance on the negative side of the power supply when conditioning the pipes. 2. Start at half an amp on the signal generator and after 25 minutes switch off for 30 minutes. 3. Then apply 1 amp for 20 minutes and then stop for 30 minutes. 4. Then apply 1.5 amps for 15 minutes and stop for 20 minutes. 5. Then apply 2 amps for 10 minutes and afterwards stop for 20 minutes. 6. Go to 2.5 amps for 5 minutes and stop for 15 minutes. And 7. Go to 3 amps for 120 to 150 seconds. You need to check if the cell is getting hot. If it is, you need to reduce the time. After the 7 steps shown above, let the cell stand for at least an hour before you start all over again. You will see hardly any gas generation in the early stages of this conditioning process, but a lot of brown muck will be generated. Initially, change the water after every cycle, but do not touch the tubes with bare hands. If the ends of the tube need to have muck cleaned off them, then use a brush, but do not touch the electrodes. If the brown muck is left in the water during the next cycle, it causes the water to heat up, and you need to avoid this. Over a period of time, there is a reduction in the amount of the brown stuff produced, and at some point the pipes won't make any brown stuff at all. You will be getting very good gas generation by now. A whitish powdery coat of chromium oxide dielectric will have developed on the surfaces of the electrodes. Never touch the pipes with bare hands once this helpful coating is developed. Important: do the conditioning in a well-ventilated area, or alternatively close the top of the cell and vent the gas out to the open. During this process, the cell is left on for quite some time, so even at a very low rate of gas production, you can get gas accumulating in serious quantities which would be a hazard if left to collect indoors. The greatest difficulty with Sandmeyer's design is the extremely accurate frequency signal which needs to be fed to the cell in order to achieve the degree to which the cell is needing. The cell is filled with water, and ideally we want to find the ideal frequency for that particular level of water and then lock onto it, and we want the circuitry to then adjust itself automatically. Dave Lawton has done this, and the phase lock loop circuitry which he used is shown here in this diagram, and I'll leave you to check the diagram out yourself and build it if you're good with the electronic circuits. This circuit has been used very successfully by a number of people. One experimenter had the circuit built by a friend, as he's not very confident with building electronic circuits. The construction of his build looks like this. The two air core coils are wound separately rather than as a bifilar coil, and some experimentation with different types will be undertaken to see the effect on overall gas production. This circuit is shown in the following video, driving a 2.6-inch long pair of electrodes with a 2mm gap between them, sitting in a test cell. The electrodes have seams and are made of an unknown quality of stainless steel and can be seen at the top of the photograph above. In other words, we're talking about those, that being one of the pair of cylinders. The circuit produces considerable gas production with almost no current draw, and while it's doing that, the cell remains completely cool.